ladies and gentlemen, we are going to finish chapter 17 and segue into chapter 18. And this is chapter 17. And 18 starts down here. Thionyl chloride accomplishes the same putative result. Oh, got some good vocab today. Putative result as reaction of an alcohol with thionyl chloride. The OH gets transformed into a chloride. Now, if you remember the reaction with alcohols, the first step was to react that with the most positive atom on the page. And you say, oh, I'm going to attack hydrogen then. No, I would like to tell you that a sulfur with 4 bonds to a more electronegative atoms, 4 bonds to more electronegative atoms, that's what sulfur has, is incredibly positive. And it gets attacked first. And I'm sorry? Oh, you want to attack with the other O? You can do that because you're used to activating carbonyls. I have no objection whatsoever. In fact, here, you're going to have some flexibility now. If you like the mechanism that's in the textbook and published in many videos, you can go with that mechanism. If you like this version, you can go with this version. And this version, and her logic is very good. I don't know if it is her logic. We can talk later. But this O, when it makes a bond, forms an oxonium that can resonate. The other O does not. It can't resonate. So this O is actually a superior O to the ones you'll find in other videos. Whoa. Confessions, good for the soul. And we're going to do that. And red's going to be first. She doesn't like the light blue anymore, so green's going to be second. Shows up better on this particular screen. And you're going to bring it back down. Yes. CL lead. Once again, you can use this mechanism instead of the other ones. This one would actually be a little more realistic because you generated an oxonium that can resonate. And we're going to put the sulfur on in black. It's still got 1 double bond to O. Well, it only has 1 O. And the other Cl still there. And there's a plus over here, right? Yeah. And don't forget the OH there. Yeah, we can use the N to attack the H. Which H are we attacking? She's got good suggestion. The what looks like an alcohol H. She wants to take it off with the N because this is a very reactive acid now. Yeah, maybe. I got to point out something. This thing you made here, it has a pKa now that's even lower than 5. Because if you resonate up to the O here, it neutralizes it, right? Normally, you're talking about an O minus resonating to another O minus, 2 equal resonance forms. In this case, you need to take this H off with pyridine. And this is what makes this mechanism different than the alcohol one. Because the alcohol one, you know, you couldn't take the H off because it was a 17, right? Pyridine's not strong enough to do that. 17 doesn't go towards 10 is what I'm trying to say. It's just not doesn't happen. But this thing is, it's very low. It's less than 5 now because of what you just did. You better take the H off, that's all I'm saying. And that's the same in both mechanisms. You got to take this H off now. Whether it's not as good a base as pyridine, so I prefer you use pyridine. It's wrong. She asked if she could just use the Cl- that she made, and I had to say no. Because Cl- is just too weak of a base to grab that H. Pyridine's quite a bit stronger. Even though it's not strong, it's quite a bit stronger. Very stylish arrow there. And we got an O, S double O C L, and we have an O minus. And what else do we have on there? We have a double bond and a plus. Sorry, didn't copy it properly. And yeah, the Cl- is now, it's got an option. Here's the story. Yeah, I'm about to. But I think my only option here with your mechanism is this. Break pi, right? Neutralize that O. Got your new Cl on here. And you got an O minus just ready to finish the game for you here. What do you think I mean by that? You can make everything you need to now. All 3 products can be made right now. This one, this one, this one. Talk to me. Yes. Yep. And kick off. This is the cool part. Chloride, excellent leaving group, but it doesn't leave. Why? The only way an excellent leaving group doesn't leave in a reaction where something's got to leave is that there must be a better leaving group somewhere. And there is. It's a gas. Yeah. But we can't make it directly. Now, guys, I'm going to tell you, 241, you did this. I'm still accepting it. Some of you did it last test. I said, okay, it's fine. But in reality, this is not what happens next. Because you just broke a sigma before a pi, correct? So what would be a better alternate for that arrow that I just did there? I think I just said, right? Break the pi. Step 2 in green, right? It comes back and kicks off your Cl-. But if you did it with that original red arrow, I'm just going to keep adding the same comments every time on your test, but not taking points off. Because it is in the textbook for 241. This is more accurate. You break pi's before sigma. And that gets us there. I know we're running out of time, huh? I think it's actually pretty nice. We're going to pick up with those chapter 18 reactions on Wednesday. Sounds logical. All right. We got that. So you hold on to this. I'm going to give you credit for one activity here. And we're done for today. See you on Wednesday.